electricity unit is on the topic specifically called current electricity. That is as opposed to static electricity, which you did in grade 9, static electricity. We're not going to talk about it though, very specifically anyway. What we're dealing with current, this is actually a review, but it's been a long time. Current electricity is motion of electrons through a conductor. That's what it is. You have some conductor, it could be copper wiring is the common one, and there's electrons flowing through it, and those electrons allow you to do stuff, right? They have electric potential. So what is an electron again? Remember that inside every atom that exists in our body, in the universe, there's a piece in the middle called the nucleus, and then sprinting around the nucleus all over the place are these little things called electrons. And electrons will sometimes leave their atom and start to flow, and it's when they start to flow that we have electric current. So yeah, aren't they always moving? Yes, they're always moving around the atom, but it's when they leave the atom that we're concerned with. So talking about a conductor is a type of material that allows free motion of electrons. So if you look at my little picture on the left, what that's saying is, you know, if I had some, looks like a piece of metal, right? And metal typically is a conductor, electric conductor. We talked about heat conductors earlier, but these are electricity conductors, and they just allow electrons to move freely. So you bring something positive close to a conductor, the electrons will move up close to where that positive is. Or if you move something negative, they'll move away from the negative, right? Unlike an insulator, where it's not that they don't move at all. If you look over on the right at the insulator, the electrons do move, but they don't move as freely, and they don't jump around as much. And so insulators are not very useful when studying electricity. So how do you measure current? Well, first of all, knowing that current is actually how fast they move. It's sort of how fast the electrons move. And electrons have electric charge, and so it's the rate of electric charge. So it's a rate. When we talk about current electricity, you measure amps. That's current electricity. And what you're measuring is how fast are the electrons moving. And you can say, yeah, that's what it is. So when I say the term charge, we give charge the symbol capital Q, which is unfortunate. It's Q because it seems to have nothing to do with charge, and it represents a quantity of electrons. We measure charge in coulombs, and a coulomb represents a whole bunch of electrons. So when I say that something has a coulomb of charge or negative for electrons, it means it has that many, huge number, 6.24 times 10 to the 18, more electrons than protons. Okay? And vice versa. If something has a positive charge, that means it has more protons than electrons. Just a quick example with the formula. If you look at, let's say I've got Tony here working on his anti-gravity unit. Let's say he knows that in 5 minutes it gains that much charge, 4,500 coulombs. I want to calculate the current. Well, first of all, current has to be in seconds, not minutes. So I took the 5 minutes and I figured that to be 300 seconds because you multiply 5 times 60 seconds per minute. I'm looking for I. I is the symbol for current. It's charge divided by time. So it's a pretty easy calculation. Current equals charge divided by time. And the hardest part is these stupid symbols, right? Q and I. I is current, Q is charge, and Q is charge with the symbol C, or the unit C, and then current has the unit amps. And I'm sure you've heard of an amp before. Some symbols that we'll be using throughout the unit when we draw circuits. Sometimes you build a circuit with a bell, a switch, a motor is just an M, measure volts with a voltmeter, measure amps with an ammeter, resistor, power source of some kind, a light bulb. Those are the ones we commonly use. And when you build a circuit, this is a circuit diagram. So this circuit diagram has a bell, a motor, and an ammeter. So if you want to measure current, and it would be great if this is a great easy lab, only takes like 15 minutes, and it's one of the 5 or something you have to do for this unit. and it's simple, and it gives you good experience on building circuits. You set up the circuit, get your power source. When you're measuring the amps, you just connect the ammeter to the line. I'll show you when you do the lab, like where to set up the meter, but how you can measure amps. But yeah, it's really easy to set up, and it's a simple lab, so I hope you choose it. And that's really our lesson on current. If you choose to do the calculations, that's good too, because they're very helpful. And again, that's the main formula. And the hardest part is distinguishing between what's charge, what's Q, what's T, what's I. Well, T is time, that's not too bad, but I and Q. Anyway, that's it. First lesson on electricity done.